So finishing up the 6-5 notes dealing with trig form of complex numbers. Here we have some multiplication of two numbers and they're exactly the same thing. So that would, another way to write that would be 5 times the cosine of 3 pi over 4 plus sine of 3 pi over 4 I, that whole thing squared. Also, by rules of multiplying, you take 5 times 5, which is 25. And then we are to add the angles together. So it would be the cosine of 6 pi over 4 plus sine of 6 pi over 4 I. And 6 pi over the 4 is the same as 3 pi over 2. Okay. Well, if you look at this being squared, how does this deal with that? You just square 5. And how would you take this compared to that to get, how does that relate to this thing or this thing, the 6 pi over 4? Yeah, you multiply 3 pi over 4 times 2 will get you 6 pi over 4. So then, when you are raising something to a power and it's in trig form, you take the r, or the absolute value and just raise it to whatever the exponent is. And then it's cosine of your angle times the exponent plus I sine angle times the exponent. So here we have 3 cosine pi over 2 plus I sine pi over 2 to the 5th power. So that's going to be 3 to the 5th cosine of 5 pi over 2 plus sine 5 pi over 2I. And 3 to the 5th is 243. Cosine 5 pi over 2 plus sine 5 pi over 2 I, or I sine 5 pi over 2, however you want to do that. Now if you want to know what the value is in trig or in complex number form, well, you'd have to figure out these things. Which cosine of 5 pi over 2, let's see, 1, 2, 3, 4, 5 pi over 2 is the same as cosine, so that's a 0. And that one would be a positive 1. So this is 243I is the complex number. Then finally, you're trying to find the n roots of a number. So like the cube root of 2 or something. When you're trying to find n roots of a number, the easiest thing to do, or the best thing to do, is convert to trig form first. So here's trig form. And then to find the n roots of a number, you would have the nth root of r times cosine of theta plus 2 pi k over n plus I sine of the same thing. Now, in that formula, you've got the r and the r and the n, which is the root. But here we have this value of k. Well, the value of k takes on all the values from 0, 1, 2, and so on and so forth to however many roots you're dealing with. So if you're trying to find the cube roots of 2, so the value of 2 is our value, and we want to take the cube roots of 2. So first convert 2 to a trig form, and 2 in trig form would be that value right there, which is absolute value is 2, and then the cosine of 0 plus I sine 0. In degrees or radians, it doesn't matter. So now if we're going to try to take the cube root of this thing, there's 3 answers for it because it's cube root. So we are going to be using values of 0, 1, and 2 for k. So our first one is going to be the cube root of 2 cosine of 0 plus I sine 0. Second one, cube root of 2 cosine of 0 plus 2 pi over 3 plus I sine 0 plus 2 pi over 3. The third one and final one would be cube root of 2 and then cosine 0 plus 4 pi over 3 plus I sine 0 plus 4 pi over 3. And then you just have to figure all of these out. Well, cosine of 0 is 1, sine of 0 is 0, so this root is the cube root of 2. Here we have cosine of 2 pi over 3, which is a negative 1/2, and the sine of 2 pi over 3, which would be the square root of 3 over 2. So then you would have the cube root of 2 times a negative 1/2, which would be a negative cube root of 2 over 2, plus the cube root of 2 times the square root of 3 over 2 would be the cube root of 2 times the square root of 3 over 2. And then you can leave it like that if you would like. And this last one, it's the cube root of 2 times the cosine of 4 pi over 3, which is now a negative 1/2. And then plus negative square root of 3 over 2. And you can leave it like this as well, which is similar to that one. And those are the rest of the notes for this section.